everyone. For the region bounded by the graph of x squared plus y minus 4 squared equals 4, we're going to find the volume of the solid generated by revolving the region about the x-axis. So basically looking at this is a circle with center 0, 4. So let's look at this. So basically let's put this at 1, 2, 3, 4. The radius is 2. You take the square root of that. So we'll go out 2. All right. Go down 2. All right. So basically, let's, this was my 4. So I'm going to go out 2, out 2. Okay. So there's your circle. All right. Now we're going to use this formula for revolution about the x-axis given here. And we do actually have two formulas. We need to find our y, because this f of x is your y. So what we want to do is solve for y, and that's going to give us, let's see, y minus 4 squared equals 4 minus x squared. When you square root both sides, you're going to get y minus 4 equals plus or minus square root of 4 minus x squared. And then add 4 to both sides, so you have your y equals 4 plus or minus square root of 4 minus x squared. And if you look at our circle, this upper part here of the circle, I'm going to put a little line here. That is your y equals 4 plus square root of 4 minus x squared. This lower region here is your y equals 4 minus square root of 4 minus x squared. All right, so using this formula, we can let this one be your f and this one equal your g. And using the formula, then we'll get, and we're going from negative 2 to 2, and this is our shaded region here, and it's symmetric. It's symmetric about the y equals 4 line. So basically we can write this as our volume is pi times, we're going from negative 2 to 2, and then we do our f of x, which is 4 plus square root of 4 minus x squared, and then you have to square it, dx. And then for our g, we do the same thing but subtract. So it's minus pi, and we're going from negative 2 to 2. That's going to be 4 minus square root of 4 minus x squared dx. Since it's symmetric, and to make this easier, we can just go from 0 to 2. So we can just take this shaded region and then multiply it by 2 to get this side of the shaded region. Therefore, I can write this as pull out 2 pi, and then you're going to go from 0 to 2 of 4 plus square root of 4 minus x squared dx, and then minus, and we'll go from 0 to 2 for this one as well. 4 minus square root of 4 minus x squared dx. And this is all multiplied by 2 pi. Okay, so the next step is just to expand this, our squares there. So we're going to get this equals 2 pi times the integral from 0 to 2. And then we're going to have 16 plus 8 square root of 4 minus x squared plus 4 minus x squared dx. And then we're going to have minus, let's see, pi, or we already pulled out the 2 pi. Okay, so minus the integral of 16 minus 8. Just copy the same thing down, basically, x squared. And this would be plus 4 minus x squared dx. I'll put the dx out here and get rid of the integral here. So I put everything together here. All right. Now, let's go ahead and combine all this. This is going to give me 2 pi. And we're going from 0 to 2. And if you combine these two together, you're going to get 16 times the square root of 4 minus x squared dx. All right. Then let's see what else. Let's go ahead and pull out the 16. That gives me 32 pi. We have the integral from 0 to 2 of square root of 4 minus x squared dx. Now, I went ahead and did, this is a good integral to know. So we have the form of square root of a squared minus x squared. So I can integrate this as 1/4, and then I'm going to have 2 squared times pi, because my a is 2. All right, so now that I have that, and I just wrote it in this format here, this is going to give me, my integral is going to be equal to, or my volume is going to be 32, because we have to multiply this by 32 pi squared, because this is 1. So we just have 32 pi times pi. So this is your volume. Thank you. Have a nice day. Bye-bye.